A sequence is a set of quantities arranged in a definite order. An arithmetic sequence, also known as an arithmetic progression, or AP, is a sequence in which there is a common difference between the terms. Here I've given an arithmetic sequence 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, etc. As you can see, there's a common difference, and we call that common difference D. And the common difference is 2. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. 11 minus 9 is 2, etc. all the way down. In each case, our common difference between term 2 and term 1, or term 3 and term 2, or term 4 and term 3, or term 5 and term 4, etc. is 2. For this same arithmetic sequence, 3, 5, 7, 9, 11, 13, we label each of the entries of the sequence. U1 is the first, U2 is the second, U3 is the third, U4 is the fourth, U5 is the fifth, U6 is the sixth, etc. Important to note that U1 is your first term, and your D is the common difference we talked about. 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2, etc. Or U2 minus U1, U3 minus U2, U4 minus U3, etc. For an arithmetic sequence, here is what you need to know to find the nth term. If we're looking for u to the n, that's some nth term, we take the first term, u to the 1, plus n minus 1 times d. U to the n is the nth term, n is the number of terms we're looking for, u1 is the first term in the sequence, and d is our common difference. Look, we've got 4 stars here and a red box. It must be important. U to the n equals u1 plus n minus 1 times d. So here is that formula in practice. A question like this: find the 99th term of the sequence 3, 5, 7, 9, 11, 13, etc. Well, with this sequence, it's just a pattern of numbers. We're not adding the numbers, we're not subtracting numbers. We just want to know what number would be in the 99th spot. If this is spot 1, spot 2, spot 3, spot 4, spot 5, spot 6, what would the 99th spot be? Well, we take the first in the sequence, that's u1, plus 99 minus 1, because we're asked to find u to the 99. 99 minus 1 times 2, which is the common difference. Well, why is that? Well, when you do that, you get 3 plus 98 times 2, which is 199. Well, if we start here and we take a jump, each jump will be 2. So if I want to find the third term, I have to take 2 jumps. If I want to find the 5th term, I have to take 4 jumps. If I want to find the 6th term, I must take 5 jumps. In other words, I always think of this in terms of the number of jumps. If you want to find the 99th term, you're going to have to take 98 jumps. Well, how big will each jump be? The common difference. We took a jump of 2, a jump of 2, a jump of 2, a jump of 2, a jump of 2. We're going to have to take 98 jumps of 2, and we started at 3. So, for me, that formula makes a lot of sense. I hope for you too. Here's an example of an arithmetic sequence. An arithmetic sequence has a 7th term of 16.5 and a 12th term of 24. So immediately I know that the 12th term is equal to the first term plus n minus 1, because I'm using this formula. U to the n is equal to u1 plus n minus 1 times d. So if the 12th term is 24, then u12 equals u1 plus 12 minus 1 times d. u12 equals u1, 12 minus 1 is 11d, is equal to, the 12th term is 24, so I get that equation there. And it's got a 7th term of 16.5. Well, that means u7 equals u1 plus n minus 1 is 7 minus 1 times d. And it says the 7th term is 16.5. So here's my 7th term. u1 plus 7 minus 1 is 6 times d is equal to 16.5. So using this formula, I get these 2 equations. It's 2 equations and 2 variables. We can solve this linear system very easily by setting one over the other. I multiplied this second one by negative 1 to give us negative u here, negative 6d here, and negative 16.5 here. Why did I do that? Because I wanted to cancel out my first terms. And that gives me 5d equals 7.5. Divide both sides by 5, and d equals 1.5. Once I know d is 1.5, I can substitute back. I chose to substitute back into here, anywhere where I see u1 and d. I plug a d in, it's 1.5, I substitute 1.5 in there, and I solve for u1, and it turns out u1 is 7.5, and d is 1.5. So I'm careful to answer the question that is being asked. I just found out by solving simultaneous equations that u1 is 7.5 and d is 1.5. I know I'm supposed to find the 24th term. The 24th term is u1 plus 24 minus 1 times d, according to this formula. And now all I have to do is substitute 7.5 in for u1 and a d of 1.5. When you do this simple calculation, you get your 24th term is 42. A car whose value was $25,600 decreases in value by $90 per month. How long will it take for the car's value to drop below $15,000? Well, first step is to recognize that this is an arithmetic sequence. If we start at 25,600 and minus 90, we're at 25,510. Minus 90 the next month, 25,420. Minus 90 the next month, we're at 25,330. Well, if we're talking about an arithmetic sequence, then u to the n equals u1 plus n minus 1 times d is our formula. With u1 is equal to 25,600 and negative 90 is our d. Make sure you have the negative sign there. Well, we can set up this inequality. Our value of our sequence is going to be less than or equal to 15,000. Distribute out the negative 90 and you get this statement here. Combine the 90 and the 25,600 to get 25,690. And we have this statement here. Subtract 25,690 from both sides and divide by negative 90. Remember, when you divide by a negative, you have to switch the inequality and you get 118.7 months, which of course in three significant figures would round to 119 months. And that's when they're looking for how long. Well, how long will be answered in time? 119 months to three significant figures.